S. Chand presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
Hi, welcome to S. Chand Academy, and in this topic we will study about the memory allocation process. When we run the program, when we run the functions, how the memory is allocated.
I am Dr. Shriyash Atri, and these are the some good books from the S. Chand Publishing.
This is the memory allocation process. Understand the concept here. Memory architecture. The memory architecture is divided into 4 segments. One is the heap, stack, static and global, and code in text. So what happens? This heap means free memory. Okay. Stack means when we made some functions and when we made some local variables, like we have developed the recursion functions, okay, recursive functions, and x, y, z are my local variables. So all these functions, recursive functions and local variables are saved or assigned in a stack memory or in a form of a stack. Then global variable. So global variables are also allocated in a different memory, okay, and then when we the things which we have write, the instructions and code, the memory is also allocated differently, code in text, like that. So this is when one program runs, okay, the memory allocated in 4 segments. One is heap, the free memory, we need to use it. Then stack, all the function calls and variables are assigned to here. If our function is having global variable, then this part, the one part of the memory is also allocated to the global variable, and the remaining part is also allocated to the instructions. Whatever the instructions we have written, those instructions also need to save, or those instructions also need, or our coding also need the memory. So the memory is also allocated to our instructions. So understand the concept. Yes. Now understand the concept of this memory allocation using this program, memory allocation process. So here x equal to 10. This is the global variable. Global variables are those variables which are not declared inside the main function. These variables are always declared outside the main function. That's why it is called the global variable. Those functions which are declared inside the main function or inside the user defined function, those variables are called the local variables. So now this is a function prototype: output, sum and product. So these 3 functions are going to use again. Now inside the main, what happens? The one statement is written printf, result is %d and output. So output is a function call. So where it is going to call? It is going to call here function output. Okay. Now inside this, it is written, says return sum. Again the function call is there. So function here, the control goes to the function definition of a sum, and inside the sum we have declared, or it is declared, that int a equal to 5 and add variable. So add equal to a plus x. Now what is the value of x here? X is a global variable. So global variable can be accessed anywhere inside the function. So the value of a is 5 and the value of x is 10. So 5 plus 10 is 15. Now it is going to return product function. This is the product function, and the value of add is 15. Okay. So now the product function goes here. Now the value of b is, what is going to here? 15 is going here. 15. Now the value of b is 15. So 15 multiplied by 15, and finally the return pro. Where it will return? From where the function was called. So this particular function was called from here. Now this 15 multiplied by 15 is returned here, and this will return the output from where it was called. This function, this sum function was called from here. Again the 15 multiplied by 15 is here, and finally this is the output function, and this output function will return reverse the value 15 multiplied by 15, and here it will print the result. How this thing is going on? So all these are the different user defined functions. All the functions assigned the memories in a stack. Like this is the product function, sum function, out function and main function. Initially the main function was called, so main was called. Then the output was called, then sum was called, and then product was called. So finally the product was called. The value of the product was returned to the sum. The output of the sum function was returned to the output function, and finally the output returns to the main, and main printed the result. Okay, so this is called the process of memory allocation. So why we learn this process of memory allocation? Because when we study about the concept of data structures, there the memory allocation process is very important. When we study about the few data structures like or very basic data structure like stack, queues and linked list, in those the process of memory allocation is important. So that's why we have studied how the memory is allocated to the different functions, to the different variables, local variables and global variables. Now dynamic memory allocation. The dynamic memory allocation refers the process of managing system memory at runtime. Okay, when we run the program, how the memory allocated dynamically to all the functions. This dynamic memory allocation consists of these four functions: malloc, calloc, reallocate and free. So these are the four basic functions for dynamic memory allocation, or we can say the dynamic memory management. Okay, malloc means it allocates requested size of bytes and returns a void pointer pointing to the first byte of allocated space. Void pointer means we have studied in the generic pointer. The generic pointer is called the void pointer. We have already covered this topic. So you can refer that video. So the malloc is allocated to so how the syntax of malloc is this: malloc number multiplied by size of int. So how many number of memories we want to we required. So how many number of memory we required? So if we require 10, so 10 is there. Size of int is 4. So 4 bytes. So 4 multiplied by 10. So 40 bytes will be allocated. Now these 40 bytes will be allocated is of void pointer type. Void pointer type means right now it is not having any data type. So if you want to assign, now these 40 bytes can be assigned to the float variable, to the int variable or any char variable. Okay, so right now this is not having any data type, it is a void pointer type. Similarly calloc is allocate space of an array of elements, initialize them to 0. Point to be noted, calloc always initialize when the memory is allocated through the calloc, the values inside the memory is 0. Okay, this calloc initialize all the memory locations with the value 0 and then return to a void pointer to the memory. This also returns the generic pointer. Then free, the free function is used to release the allocated memory. Point to be noted, whenever we allocate some memory, dynamic memory allocation, in the process of dynamic memory allocation, when we allocate the memory, then after the completion of the execution of the program, we need to free that memory. So for that the free function is there. Now reallocate, whatever the memory we have allocated in malloc or calloc, now we need to reallocate that memory. So for that we need to use the reallocation function. Now we will study about the malloc function and we will understand what is malloc function. So malloc function reserves the block of memory of a given size and returns a pointer of type void, generic pointer. So how to allocate this? Cast type star malloc byte size, this is the syntax. So PTR is because the memory is always assigned to the pointer type variables, so that's why PTR is a pointer type. Okay, whatever the memory will be allocated, that memory will be assigned to the pointer type variable. Example, int star PTR, int star, this is that cast type, malloc 10 into size of int. That means malloc is up to here, this is a void pointer. Okay, now when we typecasting it, so int star, so this is the process of typecast. Now this void pointer or this memory, 40 bytes of memory, this 40 bytes of memory is now become the integer type of memory. Now this 40 bytes will be consumed only by the integer numbers. If instead of int, if I write float, okay, now this 40 bytes will be consumed by the float variables only. If I instead of float, if I say char, then this 40 bytes will be consumed by the character values only. Okay, so this is the property of malloc. Up to here, the void pointer will be allocated, and after doing the typecasting, then that allocated memory will be assigned to a particular variables to save the value of those particular variables. So this is the program of dynamic memory allocation. Inside the main, we have initialized the pointer type variable. I is a variable. So malloc 5 size of int, you can write the size of float as well. The size of float is also 4. If I say size of char, the size of char is 1. So if it is instead of int, if it is size of char, that means 1 byte will be allocated, 1 byte multiplied by 5, that means 5 bytes will be allocated. But right now take it as an integer, so 5 multiplied by 4, okay. So 20 bytes will be allocated as a malloc, and this is the void pointer type, and when we typecast is int star. So in that case, now this 20 bytes become the integer type, okay. Now this 20 bytes will consume only the integer values. If ptr equal to null, that means if ptr equal to null, what is here null? In the previous slide it is mentioned here. If it fails to allocate enough space as specified it, then it returns a null pointer, okay. If we are demanding a particular memory size, but that memory size is not available, and the compiler is not, or this malloc function is unable to give you unable to allocate the required memory size, then it returns the null pointer. That means memory is not available or memory is not provided. So if ptr equal to null, that means memory is not located. Else, if it is not null, that means memory is located or allocated, then enter the elements of an array. We are inserting all the elements of the array using the pointers and arrays, okay. So this is the concept we have studied in our last topic. So for I equal to 0, this is the loop, from 0 to 5 it is running, element entered at location, this is this. So this %d will print the location, and this %d will print the pointer. So this is the location variable, and this is the value at that particular location, okay. So location of this ptr is, here it is, location of ptr is 82690. So this line prints here, okay. Now we have inserted all the 5 elements 10, 20, 30, 40, and when this print statement runs, this print all the 5 statements. Element at this particular location is 10. Now you can see that this address and this address is same. That means the location of memory allocation of this particular address is same, okay, because this is a base address. This is a base address. 10, 20, 30, 40 and 50. 5, 52, then 56, 60, plus 4, plus 4, plus 4. So because these are of 4 bytes. So the concept of this bytes allocation plus 4, plus 4, plus 4, we have already studied in our previous lectures. So you can refer those lectures. And in the end, we are using the free pointer function. Whatever the memory was allocated through here, now after the completion of whole process, we need to free that pointer. So we need to free those memories. So this is the concept of dynamic memory allocation, and this concept is used in our data structures like linked list, stack, graphs, trees. So in this topic we have studied about the concept of dynamic memory allocation. What is the process of memory allocation? how the memory is allocated to the functions, variables, local variables, global variables, and how the stacks are maintained inside the memory.
And these are the some good books from the S. Chand Publishing. I hope you are liking this video, so please do subscribe, like and share. Thank you.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.